Hey everyone, so this is cloud computing seminar trial run. I would like to just to have a trial of my upcoming seminar. So yeah, let's start. So this seminar will be conducted by me, and I am the founder and CEO of Cloud Engine Labs. So you can just have a scan of this QR code to check out my portfolio and LinkedIn connection, as well as my company's website. You can just scan this QR and you can just explore that as well, maybe after the session. So let's start. So this is about me. So basically, I started my IT information technology job journey in 2005. So I started as a developer and then moved on to various different roles. And I started my cloud computing journey around 2013. So from then on, I have worked on various roles in cloud and DevOps automation journey. So as I mentioned in this slide, you can see, I'm a polyglot programmer. So I have experience with various programming languages like C++, Java, recently Node.js, Python, and Go. And I am also a technical blogger. I would like to share my knowledge to the community. That's when I started contributing to blogging. I'm also a speaker in public forums, and you can see a few of the images added here. So my passion is basically to automate everything, right? So in my experience, like I have worked on developer roles and then moved on to architect role and then moved on to DevOps and cloud architect roles. So I would like to interact with people and getting to know their pain areas and do the automation for them so that their journey becomes easy. So my passion is to share my knowledge and expertise in DevOps and cloud technologies to help others succeed in their careers, right? So that is also one of the passion I have, wherein I would like to share my knowledge to the community. And I am also a career mentor to people. If anyone wants to understand how to set up their career in a developer or role or DevOps engineer role or cloud engineer role, I would be happy to help. I am also having many demonstration GitHub repositories in my account, wherein I have tried out various POCs and I have published them to for the public to access that for their use cases actually. And yeah, and I'm also a recognized community expert by AWS and HashiCorp. So these are the technology companies you guys might be knowing about. So with 18 plus years of experience, as I mentioned, like I worked on different roles. So I have experience in designing and architecting high performing software products. So I have played a role of enterprise architect in my previous organizations, and I am passionate about uh, architecting a cloud and DevOps solution and setting up platform engineering teams for the companies. So before incorporating Cloud Engine Labs, I have worked on various technology companies, including Wipro, Capgemini, HCL, Accenture, and InfraCloud Technologies. So that's about me. It's a bit of a longer introduction. Sorry for that. So hope you might be knowing my credentials on various areas, right? So yeah, let's move on. So today's session agenda is we will see what is cloud computing and what happens if cloud computing is not invented, and how internet revolution helped for cloud computing. And then we will also go through how cloud computing related to automation, and we will also go through importance of security in cloud computing. Finally, we'll end up discussing about cloud carriers in various areas. And I would like to have this session more interactive, so I would be asking questions. If anyone knows answer or willing to express your idea on the specific question, you can just raise your hands and talk about that. So let us begin the session with a quote. So you can see, right? So there is a saying, there is a saying, or there is also a meme created out of the saying, like, there is no cloud, it's just someone else's computer, right? So anyone would like to share, like, no, what does this mean? Okay, yeah, that's right. So maybe someone else, anyone else wants to answer? Okay, yeah, I think every answer is it's a right answer only. So yeah, so basically, so cloud computing is nothing but there are companies setting up infrastructure on behalf of uh, their end users, and creating the required infrastructure requested by the end user, right? So that is the idea. So yeah, in this image you can see, right, there are various systems interacting with cloud, but the cloud itself will have a multiple servers, and it will mimicking the storage and the networking and every aspect of the actual computer, and it will be multiplied using virtualization concept, right? So basically, like Amazon or anyone, any cloud provider for that matter, they are having hundreds and thousands of data centers across the world. Okay, and each data centers will be hosted with so many servers, and these servers will host the users data and the users website or whatever the things we are hosting in the cloud, right? For example, if you wanted to create a virtual machine instance in cloud, it is actually not real for us, but it is actually real in terms of the same kind of implementation being replicated in the cloud providers infrastructure, right? So that's the idea. So if I have to repeat once again, like, if we are requesting for a virtual machine instance, so it will be virtual for us, because it's not, we are just owning, right? But it is just that this particular virtual machine instance being created inside the cloud providers infrastructure, right? It will be accessible through the internet, right? So that's the idea basically. So yeah, that's what depicted in this image. The concept is cloud, but it is nothing but thousands of server mimicking the concept of infrastructure and all other components required for running a computer, right? So that's the idea. So let's jump on to the introduction to cloud computing, right? So there are various concepts in cloud computing, on-prem or on-site infrastructure, infrastructure as a service, platform as a service, and software as a service, right? So these are all different concepts. So let's start with the basic idea of what are all the layers setting up a cloud, right? So cloud computing has multiple layers. So you can see, uh, so it consists of networking, storage, and servers and virtualization. So as I mentioned, the cloud provider will be having the data centers providing these features, and on top of it they will be doing the data center configuration, so that end users can use their infrastructure for provision the VMs, provision the storages, provision databases, and whatever the component they want, right? So you can see, it has a physical infrastructure. It will be living in the cloud providers place. For example, if they are having data center in United States, in the sense the physical data infrastructure will be residing in United States uh, regions, and then in that data center they will be using the virtualization concept to mimic the networking, the storages, and the actual the provision of memory, CPU, and everything will be virtualized, and end user will be able to access that using the virtualization concept that is implemented on top of the physical infrastructure in the cloud provider's environment. And resource pooling is nothing but let's consider sorry, resource pooling is nothing but let's consider there is a physical infrastructure, let's consider it as a rack server, right? So rack server in the sense, data centers will have the computers or the servers arranged in a rack manner, right? So it's like only the servers will be arranged in horizontal racks, and it will not have any display or anything will not be there, and only the network connections and other things required to provide the functionality of the functionality to the end user will be implemented, right? So, for example, if we are having a rack server and it is of the size of 36 GB, 32 GB RAM, and 1 TB SSD in a sense, so there should be a possibility that the 36 GB RAM, 32 GB RAM, and 1 TB SSD can be pooled for many cloud users, right? So that is when that resource pooling concept coming into picture. So resource pooling is nothing but we will pool the number of users into one one physical infrastructure, so that multiple people can simultaneously will be able to access the server, right? Because one person will not be entirely utilizing the full capability of the server. So resource pooling will be helping to share the resources inside the physical infrastructure, and it will be shared by multiple users. So resource pooling will be a very useful concept in cloud computing. And orchestration and automation is nothing but we will have to have some automation in place, wherein it will be invoking some APIs to create a cloud infrastructure requested by the user, and orchestration will be nothing but via some cloud console or cloud management console, we will be able to provision and orchestrate our resources inside the cloud provider, right? And networking infrastructure is nothing but since all this rack servers needs to be interconnected, so that all the resource pooling and virtualization can be seamlessly working. So there should be a networking infrastructure that interconnects all the servers that is living in the data center, right? And the cloud API is nothing but the invocation of the resource creation and resource management in the cloud provider. And finally, on top of all this, we will need to have security and compliance in place, so that if at all, if there are any vulnerabilities happening, or if there is any hacking, those kind of things needs to be avoided. So security and compliance is also important. So these are all the multiple layers of cloud computing. So coming to this image, anyone understand like what is this image represents? Yeah, correct. So basically, like on-premises infrastructure or on-site infrastructure is like we are having a company, and we are hosting our own infrastructure, and we will have to manage everything from the data center setup to virtualization to OS installation and everything. We will also use the infrastructure to host our applications or website or whatever it is, right? So entirely this thing should be managed by us. So that's the reason, it's very users will be finding it very difficult to manage. So one or two servers we can manage, but if our user base is growing, or if our application size is growing, then it will be difficult to manage. That is when we can just use the concepts of infrastructure as a service, right? So wherein we will be only cloud provider will be only providing up to the virtualization of the like infrastructure. On top of it, we will have to install our own operating system, and we can uh, we can deploy our application and other things. And the third concept is platform as a service. So cloud provider will entirely provide till that runtime and then middleware and OS, everything they will be providing. Only we will be utilizing the the underlying layer of the facilities provided by the cloud provider, and only deploy our application and data. And SaaS is nothing but software as a service is nothing but we will be the end user of the particular cloud provider, wherein we will be utilizing the application servers or website web servers or application servers or managed services basically, right? For example, MongoDB now has managed cloud offering from all the cloud providers, right? So in that case, we will be utilizing the MongoDB's offering from the specific cloud provider. In that case, we will no need to have anything in on our place. Everything will be hosted in cloud, and we will be utilizing the MongoDB service offering from the cloud provider, and we will just use the database connection to deploy our use our we will only use the database connection for our applications to connect with the MongoDB, right? So in that case, it will be very much easier, right? So that's the idea. So let's move on to next one. So yeah, so as I mentioned, we will see why we need to go for cloud computing. So cloud computing comes up with many advantages. Like basically, we don't need to manage our own infrastructure. Cloud provider will be manage everything for us. We can only utilize their infrastructure, and we can only use that. We can use that infrastructure to host our application and whatever we want, right? So in that case, if at all if any vulnerability happening or any patch needs to be done, it will be taken care by the cloud provider, and we will only focusing on application development and the deployment process. So that is the one. And maintaining the on-premises infrastructure will be time-consuming and very much cost-consuming. So cloud provider provides the shared infrastructure or dedicated infrastructure. Based on our usage, they will provide some savings. And if you are running our own infrastructure, there are power consumption will be there, and there are so many things, right? But if you are going for cloud computing and cloud offerings, we will achieve efficiency and accessibility, right? So, and one other thing is since we are hosting everything in cloud, we can easily access things, and we can easily achieve reliability of our applications, right? So the idea of any product development companies is to have 100% availability for the end users, right? Availability and reliability. So if you are deploying our infrastructure in cloud, the reliability will be always achieved. So the flexibility is something, but we can move between different cloud providers if we are not comfortable with one provider, right? So that flexibility is also there, and there are lots of security aspects now came into picture for cloud computing. So these are all the things the benefits of cloud computing. There are three high-level concepts of cloud computing. One is public cloud, and other one is private cloud, and third one is hybrid cloud. So the public cloud is nothing but uh, so if we are it will be provided by third-party providers, and anyone will have the access to the particular public cloud offering whatever we are creating, right? And for example, in case of public cloud, we can host our demo applications for anyone to use our application and make use of it, right? In that case, we can go ahead with the public cloud infrastructure. And private cloud is nothing but it will only be accessible for one specific company's users, and there will be separate VPN setup and VPC setup, and gateways will be there, so that only the specific organization people will be only accessing that. So public cloud is nothing but we can have our website, web application hosted in the internet, wherein it can be an e-commerce website or whatever it is, right? So that can be hosted in public cloud, and internally we can have security implementation, so that our infrastructure will not be visible, but anyone can access that cloud offering. Private cloud is nothing but, as I mentioned, it will be only for the specific users in the specific organization, and especially for the organization's users only. And hybrid cloud is nothing but combination of both public cloud and private cloud, wherein it comes up with a shared security responsibility, and helps maintain tighter controls over the sensitive data. So this is the kind of three types of cloud currently available. So here is a glimpse of different cloud service provider. So I have depicted here like the comparison of the major cloud providers like Amazon Web Services, Microsoft Azure, and the Google Cloud Platform. So you can see like uh, the component of the resource name of the particular cloud offering and the name comparison between the cloud providers. For example, virtual machine or virtual instances in AWS is called EC2 instances, and Azure it's called virtual machines, and Google Platform it's called VM instances, and serverless offering is called Lambda in AWS, Azure functions in Azure, Cloud functions in Google Platform. So like that, you can just refer this table quickly, and we can just move on. So there are multiple other cloud providers also there, like DigitalOcean, Heroku, Oracle Cloud, Alibaba Cloud, and whatever it is. I have also provided the comparison of this, different cloud provider and services here. So in this slide, we'll quickly talk about what are all the application architecture examples, right? So, so the application architecture is predominantly there are two major classifications like monolithic applications and microservices application. So monolithic application is nothing but we will be having an UI, and the UI will be doing some 10 functionality in the sense the backend for that particular UI will be having all the 10 functionalities as a one single library. So wherein, for example, if you are having a net banking application, let's consider. So net banking will be having so many features like money transfer and balance checking and third party transfer and bank statements and whatever it is, right? So in monolithic application, if you are considering, UI will be accessing that backend, and backend will be having all the functionalities bundled in the single library, right? So, and that is the monolithic application. And as part of monolithic applications, there are three types of application structures are there. Like one is single tier, and second one is two-tier application, and third one is a three-tier application. So single tier application is nothing but UI, backend, and database. Everything will be hosted in same server. And two-tier application is nothing but UI will be UI layer will be separated, and backend and database will be hosted in same server. And three-tier application is nothing but all the three layers of UI layer and backend layer and the database layer will be separated, and it will be hosted in different infrastructures basically. So the final one is like microservices architecture. Anyway, like I'll come to that. So in this case, the two-tier application, the concept is, if you are seeing how this will be implemented is there are concepts called virtual private clouds, right? VPC network. In networking terms, we will be separating out the UI layer with one set of subnets and backend layer in another set of subnets, right? So that is the idea of two-tier. And three-tier application is also something similar, but in that case, public facing UI layer will be hosted in one subnet, and backend will be hosted in private subnet. Database will be separately hosted, detached from the UI and backend, and it will be only accessible via the particular host name of the database and vice versa, right? So that's how it will be implemented. So this is the monolithic architecture's three-tier application, three types of application types, architecture types, and let's jump on to the microservices, right? So what is microservices architecture? Anyone have any answer for that? Okay, so microservices architecture is nothing but like, let's consider the same net banking application, right? So in monolithic application, as I mentioned, the entire backend functionalities of all the features will be bundled in one library. But in microservices application, that one library will be split into multiple modules. For example, net banking, money transfer will be a module, balance statement checking will be a module. So like that, each module will be separated and will be hosted in separate backend layers, right? So, and in the front end, it will be accessed via widget kind of application or front end. For example, a net banking, in the net banking application, if you are considering money transfer as a module, so in the UI, it will be separated out from the overall functionality. And while developing also, it is easy to develop a UI feature of the particular net banking application's money transfer. And the backend layer will be only of the money transfer, like a money transfer application will be access to, like connected to the only the backend of that particular like the money transfer application, right? So it will be like easy to develop, as well as like we can have the like a faster time to market. For example, if you are having a product idea, and if it is if the product idea is having 20 different features, each 20 different features can be built in this different module concept, so that we can we can release the products feature one by one, so that we can also see the quick return of investment for our product development, right? So that is when this microservice applications and all coming into picture. So this is like microservices application follows a multi-tier architecture concept. It will be like the evolution of three-tier architecture, wherein UI layer will be separated and the backend layer of the particular UI feature will be separated out, and everything will be having separate libraries accessing the particular feature of the UI, and database will be configured accordingly to the respective backend feature, right? So in the as I mentioned in the three-tier architecture, multi-tier architecture also will have the database layer as a separate layer, so that if at all if we wanted to destroy the backend servers that is hosted after taking the backup, right? So we can disconnect the database connection for the server, and we can recreate the infrastructure, and we can reconnect the database, so that that persistency will be achieved, right? So these are all some of the high level concept of microservices. Microservices architecture, that itself is a bigger concept. For that, we can have a separate session if you guys want. Okay. So this is the idea of kind of security fundamentals in cloud. So you can see there are three major classifications, like in cloud security, people security needs to be managed, and data security needs to be managed, and infrastructure security needs to be managed. In people security aspect, the user authentication and access control to the specific users, and secondary approval for the architecture. Secondary approval will be secondary approval will be added, and that will be for the people aspect of the security. And infrastructure if security, in the sense we will need to separate out the back-end infrastructure, front-end infrastructure, and database infrastructure. So that will be achieved by the boundary enforcement. And logical segmentation is nothing but we can have a separate subnets for in networking ways we can manage the layers using the segmentation using subnets. And the configuration hardening is something like every organization should have a security policy in place for their infrastructure. For example, it should have the latest updates installed, and it should have the SE Linux enforcement disabled. Some similar to that, there are lots of security hardening rules are there. So every organization can adopt their own hardening principles, and each infrastructure needs to be hardened using that particular hardening rules of the particular organization. And key management is we need to rotate the keys every now and then, so that if hackers have the access to the keys, they may not be able to access it after the key is rotated, right? So that is also one of the security aspect. And with respect to data, it will be encryption, data encryption. As you are aware, we need to store the data after encrypting it, and we will have to access the data after decrypting it. And we have to classify the data classification using confidential, public access, and similar to that, there are lots of classifications there. We will have to manage data with that classification. and data discovery and related to identifying the what kind of data is being accessed by the user and for the analytics purpose, right? So these are all something related to data, and we will also need to have the logging and reporting for the infrastructure and data data aspect of the particular cloud, so that we can have a eye on what is happening with the or cloud cloud access, someone should not be misusing the access, right? So those kind of things will be easily directed if you are having a proper logging and reporting mechanism, right? So yeah, that's about it. So now let's consider a story, right? So there are two fictional companies called Do Cloud and Don't Cloud. Okay, so both of the companies are solving the same problem. Okay, and no, they are also, both of them are no, web application development companies developing product for different clients, right? And as the name suggests, Do Cloud follows the adapted the cloud and automation strategies, and the Don't Cloud doesn't follow anything, right? So the the Do Cloud has a very good return of investment for their clients by achieving the cloud and automation aspects, and Don't Cloud having the siloed teams and no automation concept, and there are lots of issues because of the like no, because of the because of not adapting the automation, right? So these are all the things actually, so due to this reason, Don't Cloud has been failed for getting customer success, but Do Cloud was achieving greater success in customer satisfaction, right? So how how the developer efficiency important here, right? So how Do Cloud succeeded? That's the idea, right? So they adapted faster development and deployment model because of the cloud computing adoption. They are able to develop the applications, develop and deploy the applications faster using CI/CD implementation and security implementation, and access to services and APIs. So cloud providers having a vast cloud providers having exposing their services APIs, so that it will be easily accessed using APIs. And the Do Cloud also followed the collaboration and teamwork. So from the top management till the the junior developer, everybody is having the same team mentality. So they are succeeded, and everybody followed the rule of fail fast and act fast. Uh, Mentality. So using the cloud adoption, developers can experiment things by creating different infrastructures in cloud and deploying, destroying. So these are all the things achieved by the automation capabilities provided by the cloud provider, right? So, one other point I wanted to stress out is like access to services and APIs. So cloud providers offers vast array of managed services and API that developers can leverage to afford the common task and focus building the core functionalities. These services include databases, machine learning, analytics, and messaging, among the others, allowing developers integrate advanced features into their application without reinventing the wheel. So, Do Cloud basically succeeded by having the better developer efficiency and team collaboration, and especially using the different services of cloud provider, right? So that is the that is the point I would like to reiterate here. So adapting and embracing cloud journey is for successful for any companies. So these are the career related to cloud computing. So first one is developer career path is a full stack developer. So there are different areas are available in development. Like one is front end development, second one is back end development, and third one is database querying and writing the efficient queries to fetch the details wanted from the database, and DevOps is something like integrating the entire development till the deployment using the automation, and the mobile app development. So these are all the full stack technologies. So full stack developer is who can be a full stack developer in the sense anyone who is who is able to develop front end, develop back end, and also able to develop SQL queries to fetch the details, and they should be also able to containerize the application and deploy it in the automation using CI and CD concept. And then finally they should be also able to cross platform development using mobile application development, right? So full stack developer is nothing but they need to do end to end of all the aspect of development, and it's actually an high paying job in the market right now. So there are different technologies I have highlighted here, JavaScript frameworks are there, and HTML, CSS, and there are different frameworks are there. Backend development is nothing but again JavaScript, Python, Ruby, and Mern, Mean Stack, and all. And the database is nothing but MongoDB, SQL Server, MySQL, and Cassandra, whatever it is, right? And DevOps is nothing but that DevOps itself is a separate career path. I also mentioned at the last actually. So full stack developer needs to know how to develop and deploy the application automatically, and there is a separate career path available as a DevOps engineer for cloud engineers. I have depicted out here, right? So that is the first one is full stack development. That is a developer career path. So next one is cloud engineer career path, wherein it will be more about providing the solutioning for the cloud infrastructure, and there are various stages are there cloud developer, cloud DevOps engineer, cloud data engineer, cloud solution architect, and cloud operations engineer. So cloud developer would be able to we can relate it with something like someone who can be a full stack developer, right? They should be also needs to know how to use the specific cloud provider services for deploying their applications, right? So they are like a cloud provider in that case, right? And similarly, cloud solution architect who will be able to architect the entire infrastructure in the cloud, right, using different cloud services. And cloud DevOps engineer is especially specialized in the high level infrastructure architecture of the cloud provider, as well as they should be specialized in the DevOps tools provided by the cloud provider, and or the general DevOps tools knowledge they should be having, right? And the cloud data engineer is nothing but related to data analytics and data scientist related roles. Cloud operations engineer is nothing but how to maintain the cloud infrastructure in the cloud, right? So it's a kind of overlap between cloud architect role and cloud DevOps engineer role actually. So this is about cloud engineer path. And finally, my favorite DevOps engineer career path, wherein there are different roles are available. From the DevOps engineer is the beginner role, and people can know about the various tools in DevOps. So, so DevOps concept is nothing but developer will be developing the application, right? But at the times, what happens, right? Developer will be focusing on solving the problems of deployment and what is happening with the server and those kind of things, right? That is when this DevOps team comes into picture. So they will be automating everything on behalf of the development team, so that development team can only focus on developing the features, and the rest of the things will be managed by the DevOps team, right? The DevOps architect is who will be able to assess the infrastructure requirement and cloud deployment requirement, and they will be able to provide the solutioning for the continuous integration and continuous deployment and delivery integration. And DevOps consultant is nothing but who can provide a consulting for providing the solutioning for DevOps concept. And CI/CD engineer is specialized in the CI/CD tools of the cloud providers and as well as the other tools available in the market. Infrastructure engineer is nothing but automation, infrastructure automation related roles will come. And site reliability engineer is nothing but it's an overlap between the cloud operations, DevOps, and developer like aspects of the role, wherein SREs will be mainly focusing on achieving the reliability of that application by monitoring, application monitoring, and infrastructure monitoring, and performance monitoring of the application, right? So that is about SRE role. Automation architect. So automation architect is who can provide architecture for doing the automation, and system administrator is a kind of the basic need for any DevOps engineer. System administration still is a basic need for any DevOps engineer and cloud engineer role. And release engineer and release manager is nothing but whenever there's a bigger project, there should be a dedicated release manager who will be taking care of the releasing the application from the developer to test engineering, testing environment, testing to the production environment. And finally, there are overlapping roles like Scrum Master and Agile Coach. That is a different type of role altogether. But there is a. I just wanted to depict these are all these are the kind of carriers related to cloud computing, right? So yeah. So these are all upcoming trends in cloud computing. So now we have seen AI and machine learning are taking over the world by storm, and there is also different trend for data science and data analytics and data engineering related roles in cloud computing. And the cloud computing is closely related with IoT integration, and blockchain and Web3 technology is also utilizing the cloud computing nowadays. And the hybrid and multi-cloud adoption is also adopted by so many companies, because each provider has a specific area of expertise. So people who are capable of paying more money to cloud, they are adapting multi-cloud strategies nowadays. So as a recap, we have seen what is cloud computing, and discussed about how cloud computing is used currently for adapting the faster time to market to the product companies. And we have also seen different layers of cloud computing, and we discussed about what are all the different cloud career path. We have also seen what is the story about a do cloud and don't cloud company, wherein do cloud able to succeed well by adapting the developer efficiency provided by the cloud computing capability. So that's about it, and I am now open for questions. You can just ask me any questions if you want, and or you can post the questions in the chat. Okay. So I have formulated a quiz for this session. So you can just scan this QR code and attempt the quiz. So we are coming to the end of the session now, and I would like to hear your feedback on the session, and you can just scan this QR code and provide your feedback. Okay, so yeah, and that's about it. So yeah, thank you guys, and thank you for listening to me all the time, and let's wrap up. Yeah, thank you.